Hi everyone, in this video I'm going to be making the Simon Says game from our popular Arduino Starter Kit. If you have the kit you can follow along with the video. If not, we do sell all the bits as a little bundle. I'll add a link below for that. As well as your development board, you're going to need jumper wires, a breadboard, and you'll need to collect together 5 220 ohm resistors, 4 LEDs, one red, one blue, one green and one yellow. 4 breadboard friendly switches and a speaker. Now you will wonder why I said 5 resistors when there are only 4 LEDs. That's because the additional resistor is for the speaker. I will explain this when we're connecting the speaker later on. So let's start by stepping through the physical connections. The book that comes with the kit includes a diagram to follow, but we can figure this out by looking at the code too. So we're going to do it that way in the hope that it gives a little more understanding of what the code's being used to do. We're making these connections, but we're not going to apply any power until later on. So let's pull up code and minimise the camera slightly so that you can see the code. There we go. Right, so the first thing we're going to do is we're going to pop in the LEDs and the switches. These should be lined up to make playing the game easier. You may already know this, but you need to ensure that you never connect LEDs directly to the Arduino without a resistor in series. It can cause permanent damage. In this case, we're adding them in, but we're not going to be applying power until it's all connected, by which point the resistors will be in place anyway. So we'll need a switch, an LED, go for the red one. The shorter leg is the negative pin or cathode, and that's the one that connects to the digital pin of the Arduino. The longer leg is the positive pin or anode, and this connects to the resistor. So shorter pin, and you can always go ahead and trim these pins, but I don't see a need. So we're just going to repeat that to add the other switches and the other LEDs. You might zoom in on that to show you that properly. There we go. So each of the LEDs are connected to a digital pin on the Uno Plus. If we look at the code here, we can see the red LED is connected to digital pin 12. So we need to connect one end of cable to the breadboard in the same row as the negative LED leg. So again, that's the shorter leg. So let's strip some cable. To retain the red and the black for power and ground. So let's use brown. So as I said, we connect one end of the cable to the breadboard in the same row as the negative LED leg, the shorter leg. You see? The other end goes into the header marked pin 12 on the Uno. we're going to repeat this for the yellow, green and blue LEDs and then come back to the switches. Each of those LEDs needs a current limiting resistor placing in series with the LED. So one end of the resistor connects to the same row of the breadboard where the positive long LED leg sits, and the other end of the resistor connects to the breadboard's positive power rail. Again, you can trim these down if you think it's going to help you to get them in there properly. Right. So on your breadboard there are two bus lines, sometimes called rails, across the bottom. One is marked with a blue or black, blue in this case, minus, and one with a red plus. The plus line is where we'll later add power and the minus is the ground. So all we've done here is we've placed each of those resistors in line with the positive leg of the LED and then into the power rail. Now let's move to switches. Each switch is connected to a digital pin on the Uno Plus and is then grounded on its other pin using a short wire. We're just going to continue to use these wires for now. So again, using the code we can figure out which button needs to go to which pin on the Arduino. So let's actually connect these up so that you can see what I'm talking about. So the first switch on the left, which is red one, will connect to pin 13. So we get the other brown wire, connect it to the corresponding rail on the breadboard for the button's first pin, and then into the header marked 13 on the Uno. Now we need to repeat that with these others. So each of those switches now need to be grounded. We're going to pop a jumper cable into the line below the other leg of the switch and then into the ground power rail at the bottom of the breadboard. So into the breadboard, same rail as the other switch leg, and then into the ground on the breadboard. Now let's get you a close-up of that again. I will add the diagram for this onto our blog. At this point your LEDs and switches are ready to go. Now we'll add the speaker. It's extremely important to note that this shouldn't ever be connected to your development board without the resistor in place, as it can cause permanent damage in the same way mentioned previously about the LEDs. So as you can see here, the code defines pin 5 as being connected to the speaker. So push the speaker into your breadboard but make sure the orientation is correct. For the purpose of this video, we're orienting it so that the plus on the speaker is to the left. Once in place, add your last resistor to the positive side. So plus and to the left. So once in place, add your last resistor to the positive side of the speaker and the other end to the breadboard's positive power rail. There and there. Now you need to add an additional jumper cable from the other pin of the speaker. Let's use a purple. From the other pin of the speaker. Actually put that a little bit too close down. Let me move that up the breadboard slightly. So the other pin, and then this goes to pin 5 on the Arduino. Now we're all set to add ground and power lines. Try to stick to black and red wires for these. If you get into the habit, you'll always know that you've connected them correctly. So I'm going to use black wire to connect from the breadboard's ground rail to the ground pin marks ground on the Uno. Ground. We'll use this down here to ground. Okay. Now use a red cable. Don't worry if you don't have the black and red wires, by the way. It's not necessary, it's just good practice. But anyway, pop the cable from the rail marked with the plus on your breadboard. This is the positive rail. And the other end into the 5-volt header of the Uno, the Uno Plus. So we're all sorted. So let me just quickly run through the code. We do provide this code as part of the kit, so it can be downloaded and copied and pasted into the development environment, but I just want to run through it to explain the sections. I'll also add the code to the blog. We've already covered the define section, which is basically assigning pins to specific labels. We later use these labels instead of the pin numbers. Using readable descriptors instead of pin numbers really helps when it comes to coding. So here our LEDs will illuminate when a button is pressed, so or when it's told to do so randomly, meaning it's an output. Here we make sure the code knows to set the LED pins to outputs. And then we set the pins connected to the switches to inputs. Remember, we're pressing them to make something happen, so we're physically inputting something here. So this tells the equipment to wait for a button press to begin a game. Once a button is pressed, all the LEDs will light up, then go out. At this point, the generate pattern code generates a set of random colours. Once the LED is turned on, you press the corresponding switch and the code will check to see if you've pressed the correct switch or not. If you did, it will then move to the second level, which adds another LED blink. Press 2 switches now, and again it'll check to see if you've got them right. If you have, it will then illuminate 3, and you get it. So let's upload this sketch to the Uno Plus and have a quick go. Actually, let's compile that first just to double check there's no problems. Now, okay, so upload. So press any button to start the game. Ooh. Okay, so I take zero responsibility for your lack of productivity once you get this thing up and running. Enjoy. Please consider liking the video and subscribing to our channel, and I'll see you next time.